Assalamualaikum and greetings. In this video, we're going to take a look at the oxidation reaction of alkene compound. There are three reactions that can happen to an alkene for oxidation. The first one will be the combustion. Second one is ozonolysis, and the third one will be the hydroxylation reaction. Let's take a look at the combustion reaction. In a complete combustion, whenever we have an alkene, in general we write it as C N H to N and react it with oxygen, it will produce carbon dioxide and also water. So whenever a complete combustion occurs, the formula that we can use is CnH2n plus 3n over 2, which is resulted into n number of CO2 and n number of H2O. Please take note that this equation can only be applied to an alkene in aliphatic form. For instance, if we are using butene, the N is 4, the formula will be looking like this: C4H2 times 4 plus 3 times 4 over 2 oxygen resulted into 4 CO2 plus 4 H2O. So as you can see here, we're going to complete this equation, then it will become C4H8 plus 12 over 2, which is 6 oxygen and 4 carbon dioxide plus 4 mole of H2O. Again, this formula is only applied to an alkene in the aliphatic form. In another example, let's say you are given 2,3-dimethyl-butene. The first thing that you need to do is you need to draw the structural formula first. For instance, 2,3-dimethyl-butene will be looking like this. You need to identify first the correct number of the carbon. So in this case, we have 1, 2, 3, 4, 5, 6 carbon together with a single alkene double bond. The C is 6, the H is 2 multiplied by 6 will be 12, plus 3 with 6 is 18, divided by 2 it will be 9 oxygen, resulted into 6 mole of CO2 plus 6 mole of H2O. So you can check whether it is balanced or not. And that's it, the combustion reaction for an alkene compound. If you are given a multiple alkene group or a cyclic alkene group, you need to balance the equation manually. The second reaction that we're going to look at is the hydroxylation. This reaction is also similar to the addition reaction, which involves the symmetrical and also the asymmetrical reagent. So if we have an alkene, C11C, reacted with a cold potassium permanganate in acidified medium, this reaction will break down the pi bond of the alkene and transform it into a single bond. The pi bond, which has been broken, will attach to the hydroxyl group and thus producing a diol compound. This reaction, which also uses potassium permanganate, is also known as a chemical test, which is the Bayes test. The Bayes test is being used to identify unsaturated hydrocarbons such as alkene and alkyne, compared to the saturated hydrocarbon like alkene. For instance, if we have pentene, the double bond is located between carbon number 1 and number 2, and we apply the potassium permanganate. The reaction will occur at the first carbon and the second carbon, since that is the location of the functional group. Again, the same thing happens. The pi bond will be broken to a single bond, and both carbon 1 and carbon 2 will attach to the hydroxyl group. For the Bayes test, you will notice the changes of color from purple to dark brown precipitate indicates the formation of the manganese oxide ion. In another example, if we have a cyclic alkene, for instance, cyclohexene, and we have a double bond there, react with a similar reagent, which is potassium permanganate. The double bond will be broken while the sigma bond will maintain the same. It's going to form a cyclic compound of cyclohexane with an addition of 2 hydroxyl group at the first and the second carbon. Again, if this is a Bayes test, you will notice the changes of color from purple to dark brown precipitate for the unsaturated compound. The final reaction will be ozonolysis. Based on its name, we're going to use ozone and a catalyst in order to break down not only the pi bond but also the sigma bond of the alkene compound. So let's say if we have an alkene, which is C double bond C, and we're going to apply ozone catalyzed by Z. This reaction will break both of the pi bond and sigma bond into 2 compounds, where we're going to get carbon with a double bond on the other side, plus another carbon on the other side. Next, we're going to add the oxygen from the ozone so that the end product will become a carbonyl group, whether it is aldehyde or ketone compound. For example, if we have pentoene, reacted with the ozonolysis reagent, which is ozone and zinc, please take note on the carbon 2 and carbon 3, the pi bond and the sigma bond will be separated, resulting into the following products. This is the third carbon, this is the fourth carbon, this is the fifth carbon. At the third carbon, we have the double bond structure, plus the first carbon, the second carbon, and the second carbon having a double bond structure. And we're going to add oxygen to it. So in this case, as you can see, both compound that has been produced is an aldehyde compound. Again, this reaction involves the breaking down of the pi bond and the sigma bond and the addition of the oxygen. In another example, we can have a cyclic alkene. For instance, butene. We're going to apply the same reagent, which is ozone catalyzed by zinc. The double bond will be broken. Take note on the position of the carbon. The bond is being broken between carbon number 1 and number 4. So we can simply draw the structure like this. 1, 2, 3, 4. And then at the first carbon, we have a double bond together with the fourth carbon. We also have double bond. And simply, we're going to add oxygen at the end of the double bond. This is the first carbon, second carbon, third carbon, and also the fourth carbon. Please take note that only the double bond and the sigma bond between the first carbon and the fourth carbon has been broken, while the bonding between number 1, number 2, number 3, and number 4 carbon will remain the same. So there you have it, the 3 oxidation reactions for an alkene. We have combustion, hydroxylation, and also ozonolysis. Thank you for watching. Please leave any comment on how to improve the presentation of this video. Goodbye.